Alright, now what we're gonna do is we're gonna create another contract called contract C. And what are we gonna do is we are gonna copy this function. Okay, we're gonna say this is the contract C, and now we are gonna do something called multiple inheritance, which means we are going to inherit from multiple contracts. Okay, however, there is an error. The problem here is that we are inheriting from multiple contracts that contain the same implementation. And by doing that, we are forced to use a feature of Solidity called function overriding. Okay? Which means that the base contracts need to specify the functions as virtual. And then the contract A will need to call explicitly or will need to override a particular implementation. So what we're going to do here is we are going to say that this function is virtual. We are going to say also that this function is virtual. And now in the contract A, we're going to say function who am I that overrides the contract B, the contract C, that is going to be external, pure, and it's going to return a string memory. Okay? And then here what we can do is return contract B dot who am I. Okay, there is a small problem. We need to change this to be public, this to be public also, and now and this one to be public. Okay, and then this is working. Okay, now we are saying that who am I is overriding both implementations from contract C and B, and then we are calling explicitly the function from contract B. So let's test. Deploy, and then who am I? I'm contract B. Now we can do something different. Let's imagine in this moment that sometimes you want to call contract B who am I, but in other times you want to call contract C who am I. How do you add this dynamic behavior in the contracts? You could do it by having a enum. Let's say we create a enum called type, and this is going to define some values. None, contract B type, and contract C type. Okay? So what we can do is we can define a variable called type that is going to be called contract type. Okay? And then let's create a constructor. And in the constructor, we are going to initialize the contract type that is going to be equals to an option that we are passing during the creation of the contract. And this is going to be called initial type. And we simply initialize as initial type. Okay? Now that we have this contract type, we basically can do this. We can say if contract type is equals to type dot contract B type, then we return the contract B implementation. Okay? Now we can say if contract type is equals to type contract C type, then we return contract C dot who am I. Okay? And if none of those options are specified, what we can say by default, return contract A. Okay? Alright, so there is a problem. Let's see. Okay, this is declared as pure. However, now we are accessing state variables. For that reason, this has to be a view. The same case for the contract B who am I implementation, and the same case for this implementation. Okay, and now it's working properly. Let's test. I have contract A selected, and I'm going to specify, let's say 0. I'm deploying, and then if I ask who am I should expect to get contract A. Okay, I have contract A. Now let's add another function to allow us to modify the type, the contract type. Let's create a function called change type that is going to receive a new type that is going to be simply external. And what we do is that the contract type now is going to be equals to the new type. Okay? Let's test this contract. And I'm going to say again that the default value is 0. So I should expect to get contract A. Now let's say I want to change it for 1, which is the contract B. And now let's call who am I, contract B. Now let's change it to be the contract C. Okay, and then who am I, contract C. All right, so this is a way to reuse code from base contracts, but also add some sort of dynamism to the code.